Lab 8. The objective for undergrads is to place the robot randomly in the arena, perpendicular to the wall. Then it will measure 4 distances around it. And then using those distances, it will drive along the X and Y axes to get to the middle. Here's my arena. Not all of it is walls, but I am moving boxes so that it can see where the walls would be. The dimensions are approximately 120. This end is 120. So the midpoint is 160, is 60 right there. It's a bit hard to see. In this direction, it is of a distance of 100 centimeters. And then the midpoint is 60 centimeters. It's 50 centimeters, sorry. On there. So, we will turn on the robot and run the program. So, it will measure 4 directions, and then using those measurements, it will then drive along the axes to reach the midpoint. And let's say instead of doing it here, let us do it in this direction, over, let's say here. So like that. Leave this box. So now we'll run it. Maybe a bit further. We'll run it here. It will measure in all 4 directions, and then it will travel along the X and Y axes to reach the midpoint. Now, here's my code. So, within the loop function, it has an 3-part algorithm: map, calculate, drive. After the button and waiting 2 seconds, it will map, which consists of, for 4 times, starting from 0 to 3, going from 0 to 3, where 0, 1, 2, 3 represents northeast, southwest, where north is the direction the sensor is pointing. So the first measurement, it will then store distance, which is the ultrasonic sensor's reading plus the robot's radius, which for me is 8 centimeters. That shows from the sensor to the middle. So whenever it sees a distance, it will get the distance the sensor reads plus the radius, which will then get you the robot's distance from the midpoint of the robot. So it would store that in an array of dist, and then rotate and just circle around. Then it will calculate, with the formula being for the y distance, north minus south divided by 2, and then for the x, east minus west divided by 2. That's done here. And then simply drive. It drives the y, turns, drives the x. Now, I graphed that in Desmos. So this is a representation of what we saw over there first. We'll do that. Now, the nice thing about this formula is that no matter, so let's say it was over there, let's say we increase the northern wall distance. If we increase it enough, then the midpoint is actually in the other direction than to what it was. So the formula is able to compensate to do that, in which it also helps that in my program, I actually improved the drive straight function and the rotate in place functions to accept negative values. So if it is negative here, it will activate the direction. It will set it to -1 instead of 1, and then set the dist to be positive so that it will not affect anything else. Then the now negative direction will then make several things negative, so it allows it to drive negative, which is backwards or counterclockwise. So this is just the algorithm working. This is able to be played with, and I linked it in the report. But yeah, that's the program.